So like I said, this is the last new lesson of the unit. We typically always end it off with some word problems. So the first thing we need to talk about is this new theorem that we're not going to have to use too much, but it will show up next year in Math 1 when you guys are all in high school. And that is the angle similarity theorem. We kind of touched on this with note sheet 7 yesterday. And this theorem basically states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, so we only need two congruent angles to be similar, because as we saw when we did this little angle exercise where we found the missing angles, right? This was yesterday on note sheet 7. We saw that, we knew that there was a 58 and a 58. We knew there was a 41 and a 41. Well, the only other third angle we can have here, if they all add to 180, is 81 degrees. So it's like if two of the angles are congruent, obviously the third one is congruent. So we know that these triangles are similar, right? Triangles are similar if their corresponding angles are congruent. So we need the same angle, all right? Can I get a volunteer to read this little word problem out? Darius, go for it.
While playing tennis, Matt is 12 meters away from the net, which is 1 meter high. He needs to hit the ball so that it just clears the net and let him 6 meters past the net on the other side. At what height should Matt hit the ball?
Perfect. So Matt's 12 meters away from the net. If we want to kind of understand this image a little bit, here's the net right here. There's the net. Obviously, there's the mat. Okay. Anyone ever played tennis before in here? A couple people. Very nice. Big fan of tennis. Played tennis 1 year in high school, and then I realized I wasn't very good at it, so I stopped. Just like my basketball career. But it's okay. Anyway, so you can imagine like this is like a side view of the tennis court. Here's Matt down here at the, I don't know if they call it a baseline, but at the baseline. And then here's the side of the net. All right? So he's going to throw this tennis ball up and hit it, and it's going to have a nice straight path all the way down. We want it to just get over the top of that net and then land on the other side of the net, boom, 6 meters away. Are you guys kind of envisioning this in your head a little bit?
Kind of.
Okay, good. So the distance between Matt and the net is 12 meters. I'm going to do a little arrow here so we know. The distance between Matt and the net is 12 meters. And we want the distance from the net to the landing point of this ball to be 6 meters. The net itself is 1 meter high. We need to figure out how high this tennis ball needs to be before Matt hits it. So we have 3 numbers. We've got a 6, a 12, a 1, and we've got an unknown, an x. Good morning. So we're going to set up a proportion just like we did yesterday. But first, we want to split our triangles up into 2. Go ahead. Before we split them up, though, we need to make sure, and this is more of a formality than anything, we need to make sure that these are similar triangles. So we need at least 2 angles in common. Are there any angles here in this on these 2 triangles that are in common? The right angle. Perfect. They both have a little right angle in the corner. Right, we're looking at this small triangle ABC and this much larger triangle ADE. And we see they both have a right angle. All right, that's 1. So they both have a right angle. Do they share any other angles with each other? Even if we don't know what the angle measure is, are there any angles in common between these two?
X and 1.
You said X and what?
A 1.
X and 1. So that's great. I love that. These are side lengths, right? So the angles would be like E. We got this right angle. We got that right angle, and angle A.
Oh.
Oh, and angle C up there, right? So are there any angles they have in common? Angle C? Close. We're getting closer.
B and A.
Let me. There's got to be an easier way to do this. Give me 1 second. So here's my tiny triangle, A, B, C. Right?
Is the same one the right angle? Yeah, like.
We got that one. The right angle is the same. Yes. Right? So maybe this isn't going to work. Maybe it is. I don't know. We'll see. So there's my tiny triangle. And then, actually, let's do it like this. Here's my large triangle. Right? We know they both have a right angle in the bottom right corner. But what other angle do they share? A. Right? The tip of each of these triangles is angle A. Right? I don't know if that makes sense. Does that make sense?
Yes.
Okay. So that's the second angle that they share. They both contain angle A. This is just the understanding part, okay? This isn't like what you're going to be doing on the worksheet, but I want to make sure we understand. We know that these are similar triangles because they both have a 90-degree angle. They both contain angle A. And if A and A are congruent, B and D are congruent. Therefore, C and E must be congruent as well, even though we don't know what A, C, and E are. Okay? Anyway, that's not as important as what we're talking about next. So both triangles contain angle A and a right angle. Therefore, they are similar by the AA similarity theorem. That doesn't make total sense. We'll survive.
A little bit.
Okay. It might look a little bit better when we split these triangles up. So there's my two triangles. And this is what we're used to seeing, right? This looks just like our worksheet yesterday, worksheet 80. So notice how angles B and D are both 90 degrees. And the bottom left angle in both triangles is angle A. So angle A could be 10 degrees, it could be 20 degrees, doesn't matter. We know that it is exactly the same. Because it's the same angle. So now, if we want to set up our proportion, we need to know the side lengths. How long is side AB? 6. How tall is side CB? 1. This is my little triangle right here. Right? You can even color it in like this. Right? We've got a length of 6 and a height of 1. Now, if we're looking at this whole big triangle, what's the height of my big triangle? X. So ED is X units. That's what we're going to solve for. And think about this for a second. What's the length of my base for my large triangle? Good. I love that you said 12, right? But 12 is from here to there. That's not my entire triangle, right? Ida, what did you say the entire base was? 18. 6 meters here, 12 meters there. 6 plus 12 gives me 18. So this is the tricky part. When we're doing this work today, if we can even get to it, which we might not, we got to make sure we're adding our big base together. So off to the side, let's write, don't forget to add the big bases. Because if we don't put the right number in our proportion, obviously we're not going to get the right answer out. So we'll set up our two fractions. What's the fraction that I could write for triangle ABC? 1/6? Sure, let's do that. 1/6 equals, what's the matching fraction I could write for triangle ADE? X over 18. I've got my right side over my bottom equals my right side over my bottom. I could have done 6/1, but then I would have had to do 18 over x as well. Now when we cross multiply, I'm going to do 1 times 18. I'm going to do x times 6. So 6 times x equals 1 times 18. What's 6 times x? What does that equal? 6x. What is 1 times 18? 18. How can I get x all by itself now? Divide by 6. And how many times does 6 go into 18? 3 times. So the math part of this is exactly like yesterday, right? Set the proportion up, corresponding sides in the same spot in our fraction, cross multiply, divide it out. But because these are word problems, we need units. So what is this 3 representing? Is it 3 tennis balls? Is it 3 inches? What is it? 3 meters. Look at all my numbers here are in meters. So my answer is x is equal to 3 meters. And that's my answer, 3 meters. So the key thing to remember is to add our bases together. If you see 2 numbers on the bottom, then the entire base is going to be those 2 numbers combined together. That's the key thing we want to keep in mind. So almost all of the diagrams you'll see on the worksheet are very similar. If I'm looking at number 1, I've got a street light casting a shadow over a trash can. Right, and we got to find the height of the trash can. What's the height of the street light here that you see? 9 feet. How long is the trash can's shadow? 9 feet. How long is the total shadow of the light pole? 27. Don't forget to add the big bases. I got an 18 and a 9 on the bottom. The whole base of this whole big triangle is 18 plus 9, which is 27. So that's what you want to put into your proportion. Down here, we got a person with a bow and arrow shooting down at an apple. How high up is the apple? 3 feet. How high up is the bow and arrow? X, we don't know. That's what we're going to find. What's the trail down from the first apple to the second apple? How far away are they? 6 feet. How far away is the bow and arrow from the second apple? 14 feet. 8 plus 6. Now the third one is already split up for you. And I'll let you guys figure that third one out. It shouldn't be too bad.
Is there a bathroom?
Nope. We only have 15 minutes. So hopefully we'll see how far we can get through this right now. If not, we'll just continue it tomorrow.